Okay, so get this. We're diving into something today that sounds straight up impossible, like completely
Oh,
bonkers.
I love the impossible. Lay it on me.
Water, boiling,
Mm.
and freezing
Yeah.
at the same time.
Whoa. Okay, now that's just messing with my brain a little bit. I'm intrigued.
It's this wild concept called the triple point, and trust me, it's even weirder than it sounds.
Well, you've definitely got my attention. I'm all ears. Triple point, huh? Break it down for me. What's the deal with water doing all that crazy stuff at the same time?
So imagine this. Ice, water, and steam, all just chilling together, totally coexisting.
Hold on, I thought those were like separate states of matter, solid, liquid, gas, all that jazz.
Exactly. That's what makes the triple point so mind-blowing. It's this super specific set of conditions where all three states of matter can just hang out together in perfect harmony.
Harmony, huh? All right, I'm listening. What kind of conditions are we talking about here? Is this like some top secret science experiment stuff?
Well, it does take some seriously precise lab work to pull it off. For water, the triple point happens at a temperature of 0.01 degrees C.
So basically just a smidge above freezing. Gotcha.
Right. And then the pressure has to be exactly 611 pascals.
Okay, now you're losing me a bit. What's a pascal, and how much pressure are we talking here?
Think of it like this. That's about 1100th the pressure of your car tire.
Wow, that's incredibly precise. It's like trying to thread a needle in a hurricane. How do scientists even create those conditions? I mean, are we talking like a super secret lab hidden underground or what?
Not quite a secret lair, but it does take some pretty sophisticated equipment. They use these specialized chambers where they can meticulously adjust the temperature and pressure. They basically finesse it until they hit that sweet spot, the triple point.
And at that point, you're telling me I could see ice, water, and steam all doing their thing at the same time.
Picture this. Ice crystals are forming, liquid water's bubbling away, and steam's rising, all happening simultaneously and continuously.
Okay, that's seriously trippy. But what's the big deal about the triple point? Why should we care about water having an identity crisis in a lab somewhere?
Because it's not just some random scientific quirk. The triple point is actually super important for a bunch of reasons. Like, it's a fundamental reference point in science.
Oh, okay, so starting to see where you're going with this. So how does it work as a reference point?
For starters, it's used to define the Kelvin temperature scale, which is like the gold standard in many scientific fields.
Ah, the Kelvin scale. Yeah, I've heard of that. It's all about absolute zero and whatnot.
You got it.
Okay.
And the triple point of water helps us pin down that scale with incredible precision.
So basically, every time we check the temperature, we're kind of sort of relying on this water gone wild phenomenon. That's pretty wild.
Exactly. And it doesn't stop there. This whole triple point thing also helps us understand how matter acts in really extreme environments, which is super important for space exploration.
Space exploration. Now we're talking. Always loved a good space mystery. How does the triple point play into all that?
Well, think about Mars, for instance. The atmospheric pressure there is way lower than it is on Earth.
Right, Mars has that super thin atmosphere.
So thin that liquid water is basically unstable on the surface.
Unstable how? Like, it just vanishes into thin air.
Not quite vanishing, but it either freezes solid or boils away super fast. It just can't exist as a liquid for very long.
Oh, wow. So much for finding a Martian swimming hole, huh?
Probably not happening, no. But here's where the triple point comes in handy. It helps us explore other possibilities for finding water on Mars, even if it's not on the surface.
Like what, underground lakes or something?
Exactly. If there's water beneath the Martian surface, the pressure and temperature down there might be just right for it to hang out in a liquid state, even if it's only temporary.
So the triple point is like a clue, helping us figure out where to look for that hidden Martian water.
Precisely. It's like a cosmic treasure map, guiding our search for one of life's most essential ingredients. And remember, where there's water, there could be life.
Mind-blowing. This seemingly impossible phenomenon is actually helping us search for alien life. Science is just the coolest. But I have to ask, is the triple point just a water thing? Or can other stuff do it too?
Oh, it's definitely not just water. Lots of substances have their own triple points. It's like a universal quirk of matter.
So, like, could we find a triple point for, say, oxygen or even something like rock?
Absolutely. Each substance has its own unique set of conditions where its solid, liquid, and gas phases can all coexist. It all comes down to that delicate balance of temperature and pressure.
It's like every substance has its own secret recipe for a triple point cocktail, makes the right amount of temperature and pressure, and bam, triple point magic.
It's a great analogy. And scientists actually use this concept to map out something called a phase diagram. Think of it like a map of all the different states a substance can be in.
A phase diagram, huh? Sounds like a handy tool for understanding how matter works. How does the triple point fit into that?
The triple point is like a special landmark on that map. It's the point where the lines for solid, liquid, and gas all intersect.
Oh, I see. So it's like a crossroads on the phase diagram where all three states can coexist. That's pretty neat.
It is. And studying these diagrams helps scientists figure out how matter transitions between those different states.
So this knowledge isn't just for understanding water on Mars or figuring out the Kelvin scale, right? It has practical applications here on Earth too, doesn't it?
You bet. Understanding how matter changes states is super important in a ton of fields. We're talking material science, engineering, meteorology, the list goes on and on.
So this seemingly bizarre, mind-bending concept of the triple point is actually woven into the fabric of our everyday lives. It's like the universe's hidden language dictating how everything around us behaves.
Now, one last thought to chew on. We've talked a lot about labs, but could something similar to a triple point ever happen in nature, even briefly?
Oh, for sure. Think about those extreme environments we mentioned earlier, like up on a really high mountain peak where the air is super thin, the pressure is naturally lower, right?
Right. And those super low pressures mean that water can actually exist in multiple states up there, at least for short bursts.
And the same goes for places like the thin atmosphere of Mars. The conditions are just so extreme that water can't make up its mind what state it wants to be in, so it kind of just flips between them.
So this whole triple point thing, it's not just a theoretical concept cooked up in a lab. It's a glimpse into how matter behaves in those crazy extreme environments, both here on Earth and out there in the cosmos.
It's a reminder that the universe is full of surprises, and that even the seemingly impossible can be real. Pretty inspiring stuff, if you ask me.
So let's wrap things up. What have we learned today?
Well, for starters, the triple point shows us that matter can pull off some pretty mind-boggling feats if the conditions are right. It's all about finding that perfect balance of temperature and pressure.
And this seemingly bizarre phenomenon isn't just a scientific curiosity. It actually has profound implications for how we understand our universe and our place in it.
It helps us define temperature scales, search for life beyond Earth, develop new technologies, and appreciate the intricate dance of matter in all its forms.
And it all starts with this seemingly simple question. What happens when water decides to boil and freeze at the same time?
And the answer, as we've discovered today, is a journey into the heart of matter itself. It's a reminder that even the most familiar substances can hold incredible secrets, waiting to be unlocked by those curious enough to ask the right questions.
That's it for this deep dive. Until next time, keep exploring, keep questioning, and keep wondering about the world around you. You never know what amazing discoveries await. And as always,